Hello friends, this video on gravitation part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are introduction, gravitation, universal law of gravitation, free fall, acceleration due to gravity, determination of g, motion of objects under the influence of gravitational pull, mass versus weight, thrust versus pressure, buoyancy, Archimedes principle, and relative density. So as the name says, gravitation. So what do you think are we going to study in this lesson? I'm sure even though you have not studied in detail, but all of you must be aware of the term gravity. You would have heard about the gravitational pull of the earth or the force of gravity. So these terms are quite common, right? So here we will actually talk about a phenomenon under which Earth tends to attract objects towards itself. Let us look at some of the examples or some of the things which happen in our day-to-day life. I mean, every time all these things keep happening, but that is quite strange. I mean, there has to be a reason behind such incidents. For example, have you ever noticed what happens when an apple gets detached from the tree? It falls to the ground. But the question is, why does it fall to the ground? The apple has many options. If it wants, it can fly high into the air. It can go up in the air. It can stay there itself. But why is it falling to the ground? That means there is something which is attracting it towards the ground. Similarly, when you play football, you would have seen that when you throw the ball up, what happens? After some time, the ball goes till a certain height and then it falls back towards the ground. Right? So here also, if you see, there is some attraction which is attracting the objects towards the ground. Correct? Not only that, some of the natural phenomena like rainfall. Why does the water droplets fall towards the ground? Again, because of some attraction. The planets, the movement of the planets in the solar system. Moon revolves around the Earth. Earth itself revolves around the sun. There are so many other planets which keep revolving, which keep on moving around the sun. So all these movements, how are all these movements possible? So gravitation play a role there also. So this attraction by which Earth tends to attract every object towards itself is what is known as gravitation. And this is what we are going to study in this lesson. So we will start with, the story of gravitation basically started with Sir Isaac Newton. So we will see how did Newton arrived or how did he started thinking about gravitation, and he gave the famous universal law of gravitation. So we will talk about that. So let us start with Newton's view towards gravitation. How all of a sudden Newton got the idea, or how did this idea of gravitation struck in. So let us see how did this idea actually strike Newton's mind. So there is this famous story of apple behind Newton's idea of gravitation. Once it so happened that Newton was sitting under a tree and suddenly an apple fell on his head. Now, normally this can happen with anybody, right? But normally people don't tend to think so much about it. But Newton paid a lot of attention to this incident. He started thinking, why did the apple fall towards the ground? That's because the earth attracts the apple, right? That's why the apple fell to the ground. So does that mean that the apple also attracts the earth? Or is it only the earth which attracts the apple? Now, if the earth attracts the apple, does that mean it attracts every other object? So that means every other object should fall towards the earth when left free, right? So he started thinking about this. So the next thing that struck his mind was the moon, the motion of the moon around the earth. He started thinking, if the earth can attract the apple, why can't it attract the moon? Now the question is whether the earth attracts the moon or not. Now the next question was, if Earth attracts the moon, then why don't we ever see the moon falling towards the Earth? Because every night we see the moon, right? We are able to see the moon, right? But have we ever seen the moon falling towards us or the moon falling towards the Earth? Like that apple? No, we never saw that, right? So the question which came to his mind was, if Earth attracts apple, Earth should also attract moon. Now, when the Earth is attracting apple, apple is falling towards the Earth. But why not the moon is falling towards the Earth? So all these questions started bothering him. So he started thinking about all these phenomena. So he started his research, his experiments on this, and finally he arrived at the famous universal law of gravitation. He gave the law of gravitation. So we will talk about the law of gravitation, but before that, let us see what actually governs the motion of the moon around the Earth. So how was the motion of the moon around the Earth was explained. Now the thing is that the movement of the moon around the Earth happens in a kind of circular path. Not exactly circular, kind of an elliptical circular path. Now, if the Earth would have not been attracting the moon, in that case, the moon would have not moved along this path. It would have moved along a straight line path. How? Let us look at this example. Let us suppose you have a stone, okay? And you tie a thread to the stone and you hold the other end of the thread. Now you start rotating it. Now it is very, very easy to rotate it like this. Now why do you think the stone is moving in a circular path? Because you are applying a force at the center, right? That is why it was moving in a circular path. So there is a force which is always at every point the stone is being attracted towards the center. So because of which it comes little near, again it moves in its original path, again it comes little near. Now what happens, the moment you leave the thread, what would happen? As soon as you leave the thread, the stone will fly away. The stone will move in a straight line path, right? You can try it yourself. The stone will move somewhere and fall down. Correct? So that means the stone was moving in that circular path because of a force which was attracting it at every point towards the center. And that force is known as the centripetal force. So similar is the motion of the moon around the Earth. So at every point the moon is also getting attracted by the Earth. So because of the centripetal force, it is moving along a circular path. Otherwise, the moon would have moved along a straight line path. So Newton was able to understand that, okay, fine, it is not only the apple, but it is any object that Earth attracts. So Earth attracts every object. So now the question was that, is it only that Earth attracts every object, or is it like every object attracts every other object? So that was his next question. So he was actually trying to find out an answer to this, that the Earth attracts the apple. When the apple falls from the tree to the Earth is attracting the apple. Now, does the apple also attract the Earth? So that was his actual question. So is the apple also attracting the Earth? So now he was able to find an answer to that. He found that yes, the apple also attracts the Earth. But now the next question was, if the apple also attracts the Earth, then why not the Earth moves towards the apple? For example, the Earth was attracting the apple, that is why the apple falls towards the Earth. But if the apple is also attracting the Earth, then the Earth should also move up towards the apple, right? So why doesn't that happen? We can understand that with the help of Newton's second and third law. In our last lesson, we talked about the Newton's laws of motion, right? We talked about Newton's first law, Newton's second law, and Newton's third law. So now what happens actually is that according to Newton's third law, what does Newton's third law say? It says that every action has an equal and opposite reaction, right? This is Newton's third law. Again, Newton's second law, what does it say? Newton's second law says that force acting on any object is given by product of mass and acceleration of the body, right? So now if your force is constant, if this force is constant, so from this expression we can say that acceleration is inversely proportional to mass. That means if the same amount of force acts on two different bodies with different masses, the acceleration is more for the body with lesser mass. I had explained this in our previous lesson, right? If you have two bicycles, on one bicycle there is a very thin boy sitting, and on the other one there is a very fat boy sitting. So now if you apply the same force to both of them, will both the bicycle move at the same speed? No, because the boy with greater mass, he will move little slowly. The boy with the lesser mass will move fast. So that means acceleration is inversely proportional to mass. So the same thing as per the third law, what happens? Earth will exert some force on the apple. Right? Let us suppose Earth exerts force F on the apple. So as per third law, apple should also exert an equal and opposite force on Earth. That means it should also exert the same force F. But now your force is constant in both the cases, right? But for apple, the mass is less, but for Earth, the mass is more. In this case, the force is acting on which object? Here the force is acting on the apple. So the apple is my object. Similarly, here the force is acting on Earth. So here the force is acting on an object whose mass is smaller. Remember the example of the fat boy and small boy. When you apply some force, the force is being applied on the boy. So the mass of the boy is important. So here also the force is applied on the apple. So mass of the apple is less. Therefore, acceleration of the apple is more. Right? But in the next case, force is being applied on the earth. Mass of the earth is huge when compared to the apple. Therefore, acceleration of the earth is very less and it is not visible at all. Therefore, the movement or any kind of motion of the earth is not at all visible. Right? So, was I able to explain you what actually happens? That means, so Newton concluded that every object actually attracts every other object. But we sometimes see some object, we are able to see that attraction in the form of motion in certain objects if their masses are less. But if the mass of the object is huge, in that case, the movement of the object is not visible. So this is how from the incident of the apple falling on Newton's head, he started thinking about the gravitation and he finally concluded with the universal law of gravitation. So with the help of this universal law of gravitation, he could also explain the motion of all the planets around the sun in the solar system. So it is not only the moon which revolves around the earth, it is all the 9 planets which keep revolving around the sun. Right? So they all keep moving around the sun in these kind of orbits. That's because the planets are being attracted by the sun. So at every point they are being attracted towards the sun, and because of that centripetal force, they are able to stay maintained in these orbits. That is, they do not fly away in different directions. Right? Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.